Hello, everyone, and welcome to another episode of Sneak Live. Today, we have a very, very special show for you. We are here with my pal Donut. I actually met Donut at a product security conference, and we sort of hit it off. So we stayed in touch, and he's working on some really interesting stuff in the security world. But I won't get into it too much. I'll allow him to do his own introduction. So without further ado, Donut, welcome to Sneak Live.
Hey, thanks for the introduction. Um, yeah, I'm super excited to be here. I thought it was like really kind of crazy how quick we hit it off at that security conference. Honestly, um, it was like we just had a good conversation, good vibes, good times, and it was fun to just be there and chat about security stuff too.
Yeah, definitely agree. I think it was a great conference, and you meet a lot of people who become your lifelong friends at these conferences. So we've already hung out after that conference too. So yeah, super fun stuff.
Yeah.
He's super knowledgeable, very passionate about Rust. So yeah, we wanted to hang out and talk about Rust, and I told him, hey, we can do it on a live stream, like during work. So here we are together, basically talking about our passion, right, and our work. So if you're in the audience today and maybe you find this interesting and you wanna talk about maybe some security topics, or maybe you're interested in authorization in another language, definitely feel free to reach out to us, and maybe we can schedule something as well. But today is our friend Donut's Day. So Donut, before we get into this, can you tell us a little bit about your current role? I know you're a security engineer at a pretty cool company that probably everyone in the chat knows. So can you tell us a little bit about your current role and what your job's like, and your journey to like this point in time?
Sure. So my current role, I'm a senior security engineer at Robinhood. I work on application security. I'm a huge fan of application security. It just kind of feels like a fantastic blend between my developer background as well as my security interest, which kind of teases a little bit about how I got into it. But to just kind of talk briefly about the kinds of things that I do is our a team's kind of broken up into a couple of different functions, and I specifically kind of like focus in on the like building up libraries to help minimize misuse, accidental vulnerabilities. We kind of refer to ourselves as the paved roads team. That's really kind of like the focus of my work. There is like, how do we identify those types of patterns and build out solutions that are like both easy to use and like get the job done for developers.
Wow, that's awesome. So it sounds like you really like what you're doing.
Yeah. I've actually kind of like hopped around in security a little bit, where I like tried a couple of different types of functions in the past. So like I'd mentioned before, I used to be a developer before getting into that, but like just in the security world, I did some AppSec, done some red teaming, I've done some blue teaming even. But I've just kind of come back into AppSec because it's something about it is just it just kind of tickles that right part of my brain. So yeah.
Yeah, I totally understand that as somebody who likes AppSec. So I think that's really really interesting because I had a similar sort of perspective. I think I got into application security after being a developer, full stack engineer. So, but today's not about me. So I want to know a little more about your job, though. This is totally not a scripted question at all. Is there anything from your work, because it sounds like you work on some really interesting stuff, pave road projects, etc.,
Mhm.
that probably define a lot of the trajectory for like security at Robinhood. So what I'm really curious about actually is, are there any things that you've worked on particularly like in that role that you can talk about, of course, that you're like super proud of, or that you think's like really really cool, just like as far as projects go?
I think I've worked on cool stuff that I'm proud of. I don't know how much I can talk about it yet, but it's the kind of thing that like I could totally imagine us doing like a blog post. I've already gotten some pressure from some other friends that are like, "Wow, that like thing is really cool, and you should all do a blog post on how you did that." So, maybe in the future, I'll be able to share a little bit more widely of the kinds of things that we're doing.
That's awesome. I can
Yeah.
really relate to working on cool stuff and not being allowed to talk about it because of my previous roles. So
Yeah. I'm sure red
um
teamers everywhere are just they're totally empathizing.
oh yeah,
Yeah.
totally. It's super funny actually. It's like some people in security, they can just talk on and on and on about their job, and then other people are like, nope. But I'm really curious because I know you're a huge Rustation. For those who are uninitiated, a Rustation is a Rust enthusiast. So, or maybe I'll let you define that because I'm sure there's another way that the community defines that that's better. But from my understanding, it's a Rust enthusiast, right? So, I heard you kind of like Rust. What do you like about Rust? What's a Rustation? And yeah, we'll start there, I think.
Sure. Yeah. I feel like if anything, my background should kind of give it away. Definitely a huge fan of the language. To kind of like get at what is a Rustation. I think that's just anyone that is, just that enjoys Rust, that like writes Rust. I think those are just kind of like Rustations. Kind of like how Go has the Gophers, right? Um, um, yeah, but like, what do I like about Rust? There's a lot of different aspects. I think a lot of people kind of on either side of the fence, because perhaps you may or may not be aware, Rust is a sometimes controversial topic in the like developer communities. But on either side of the fence, I think what a lot of people focus on are the kind of the main selling points of memory safety and like threaded safety or concurrency safety that Rust can offer. And those are good things. Like it's amazing that a language like Rust is both like very fast, memory safe, and is like safe in a lot of different types of like concurrent access conditions. But I think there's actually a more important story that you really kind of only come to appreciate when you've worked with Rust a bit and you've really kind of like seen what it can do for you outside of like the like tier one, memory safety and like code's just fast. And that is like the program composition problem, which is that it's like really hard to actually write software with other people. Like if you've ever like done a weekend project where you just like cool it's like 11 a.m on a Saturday, you bust the Red Bull out and you just kind of like write some code all the way until Sunday night, and you have like a full working thing, right? Got your Postgres spun up, whatever you're building for your web stack, you got like maybe a GUI done with Bootstrap, but you have something, right? And then you go into your day job and you're like, wow, this is really hard to like it takes me weeks to like get this thing from another team to like be able to like like you definitely know what I'm talking about, right? So it's a really hard process to build software, and a lot of that kind of comes a lot of that kind of comes from the difficulty of you're not an expert on every system when you're working it with other people. Other people wrote that code and other people are experts at that code, and then their expertise kind of can wane after time. So then you ask them a question, they're like, oh, I have to go dig through the code, and then you go through there and you're like, oh, you're supposed to do this thing in this particular situation. And oftentimes I'm kind of talking about it in the context of developer velocity but this also kind of shows up in quality of code too. Oftentimes uh, security vulnerabilities kind of boil down to I just didn't know the library well enough. You could imagine Log4j is a fantastic. I know this is kind of like a sinful word to kind of keep bringing up at this point. I feel bad that I keep saying Log4j every time that I want to talk about vulnerabilities these days. But
we should throw up a counter, bot counter.
Yeah. It's like the proverbial swear jar of Log4j. Anytime it gets mentioned, you put $1 in. I can go to like Hawaii on that budget by the end of the year.
Funded.
But like Log4j is I think a great example of that is that you use that library, but you weren't necessarily an expert in all of the things that it could potentially do. So how did you know that putting untrusted data in a log line was actually super dangerous? I think a lot of developers kind of view logging as almost equivalent to just print statements with extra spice,
Totally.
And so this like composition problem where I'm going to try to write some software with some other software that I'm not an expert in, and that party is going to probably do it with some of the software I wrote that they're not an expert in. We kind of start to get into the misunderstandings at that interface boundary. And this really shows up in languages like C and C++, where now you're dealing with some more dangerous things like freeing memory. And then you start seeing things like double free or UAF. So like,
Yeah.
I think Rust gives you a lot of tools to make that interface boundary incredibly friendly to the
Mm.
point where I don't even really need to interface with some of these other teams, because all of the knowledge they were going to share with me anyway has been expressed through the type system. And that's really powerful.
Yeah, yeah, I think that makes a lot of sense actually from just what I've seen about Rust and like people using Rust, right? And like obviously, we always say in security that we want to like fail in a secure way, right? Like don't default to open, right? Default to
Yeah.
closed. So I think Rust, sort of just has a lot of systems that like really reinforce that, right? Like being strongly typed, etc. The compile time checking, right? Compilation time stuff. So I think that's always been really interesting to me as somebody who's like not writing Rust, but pretty confident in like C and Go and things like that. So I think that's super interesting. Also, like two main causes of security problems or like application problems, misuse and abuse, right? So like it seems like Rust also, with that in mind, has a lot of has employed a lot of different like language. What should we call them? Language like characteristics, right? That help negate a lot of those things out the back, right? Kind of like what you were talking about with being
Mhm.
resilient to things such as like memory and it seems like a step in the right direction towards writing more secure software for sure.
Yeah.
So that being said, do you think more security engineers should learn Rust?
Yeah, in general, I'm going to tell everyone give it a try, because I think that there may be a lot of misunderstandings or misconceptions on where and when you could use Rust. Like, it's kind of fun when someone's like, "Oh, can I use Rust here?" And I'm like, "Well, actually, yes, you can." And it's kind of like fun. I'm just like, "Yeah, you want to run Rust in your browser? Like, go ahead. We can compile to WASM." Like, it's super fun. My favorite thing to tell people with regards to like where can Rust run is like it can run in more places than JavaScript reasonably can, right? You can put Rust on microcontrollers. You could put Rust on your front end of a website, and I think that's like really cool. And so I think everyone should just give it a try and see maybe if it makes sense to fit in where you typically do work and what kind of software you're building. But I think security engineers, especially those that are on the AppSec side of things, and I'll kind of get into a little bit of the other types here in a second, but kind of like the AppSec side, should maybe try it out so try to learn a little bit about how they can leverage the type system to do more work for them. Because often we're not building software in Rust. Like, I'm speaking kind of on behalf of application security engineers everywhere. Your stack is probably going to be like Python or Golang or maybe Java if you're a Spring Shop. There's a couple of different types of languages, but usually Rust is not the one that we're regularly talking about when we're talking about like, how do I secure my organization's software? Develop the software developers are writing. But I think that there's still lessons that can be kind of drawn in. Like, for example, the Golang community doesn't really lean on something called the new type pattern particularly often. And yet, with some preliminary investigation that I've done, it seems like there's not really a runtime overhead, or at least if there is one, it's very minimal for this new type pattern. But it's something that Rust will use a lot, and it actually provides a lot of additional safety. So, be able to kind of express additional concepts in the type system, encapsulating your primitives like a number. Maybe you've determined that the number is within a valid range, and so you wrap that number with a type that now has attested to that fact. Like, this is like a super common thing to do in Rust. And then when I looked into like, oh, do people use the new type pattern in Golang? I found like a Golang Reddit thread where someone's like, why would you do that? And like, I think people should explore that more. And I think Rust is kind of like a great way to do it without kind of getting into really academic languages that may require, kind of learning type theory and stuff to really get to grok a lot of the value out of it. I think there's also value in people learning Rust, like other security engineers that maybe not be the AppSec side of things, that want to build high quality, resilient software. So if downtime is like genuinely not acceptable for you, like, I think Rust is a great language for that. Cloudflare put out a fantastic blog recently where they talked about you already know what I'm talking about. Pingora, which
Oh, I
is this.
actually I shared it and then leaf tagged you in my sharing of
Yeah,
it.
yeah. Of course,
Yeah.
people they're like, oh, I see Rust tagged on it, which
I
you
knew
know,
you were going to see it, so I was like, oh,
uh,
I'm not gonna tag him in my tweet. It's like kind of like, hey,
yeah.
I'm sharing an article. Make sure you look at it, Donut, like in front of everyone. And I was just like, oh, like
uh,
I know he's already seen it.
yeah. You're not wrong, but I'll take all the tags. I appreciate it. Like just in case something slips through the crack, I got to get all the Rust articles. But yeah,
You got me
for those,
convinced. The Cloudflare thing, I think we should dive into that a little bit. And I know we're like
yeah,
running up on time here, but we should definitely talk about that. I think because I think it proves exactly what you're talking about.
yeah. Like for so just to kind of do the short version of that article, you should go read it, by the way. But Cloudflare had this problem where they wanted to try to they needed to build like basically a proxy, something that could be resilient and handle the types of load Cloudflare has, which is, by the way, it's like trillion or trillions of requests per day. Now, this is not one machine doing it. They have like a huge fleet of machines, but still, it's a lot of requests per machine because the hardware is going to be expensive. Maintenance costs on that is expensive. So like their bottom line is basically dictated on how well do we write the software, and like also how easy to maintain and keep this software running is also a big thing, right? If you have a massive SRE on call, that's a lot. Like if you have to have a fleet of people like just dedicated to keep your service alive, that's expensive for business as well. So all this is about like build really high quality, resilient, fast software. And they had this problem where they needed to build a service that could do this. So they went and looked at Rust and leaned on Rust to build the service called Pingora, which allows them to kind of like proxy this traffic between their edge and the back end services. Like the services of their customers. And I think the thing that really kind of sells how resilient software written in Rust is I don't know if I'll say is typically. I think really it is resilient, but I'll give credit to the Cloudflare engineers. I'm sure they wrote some fantastic code, but like it really kind of shows how resilient software in Rust can be, because they served hundreds of trillions of requests and they hadn't had like a software crash that was due to their code. Anytime that the software was crashing, when they investigated, it was a kernel bug, it was hardware failure. Like if the reason my service crashes is because my RAM is bad, that's awesome. I want to hear that story. I'm going to brag about that to everyone. So that's like I think that's like really kind of test, like you want to build high quality, always up software. Rust is probably a great language for you. And I think those security teams that need that type of thing, like a service that handles authentication for your platform, like I could see that, or PKI.
Yeah, so it totally makes sense for authentication and authorization because as we talked about, the goal when we're writing secure applications is to like fail securely, like if we are failing, right? So I think that makes a lot of sense. But yeah, I mean that blog was super impressive, right? We're seeing that Cloudflare's serving over 1 trillion HTTP requests in a day, right? Using Rust, using a third of the CPU and memory resources, and it goes into even more detail
Yeah.
about how incredible this is. I think it's particularly incredible. So maybe the next question I have for you here, which is like what led you to learn Rust? I think we talked a little bit about why you like Rust, and but I don't think we talked about like your journey getting into Rust. And see, we're at about like 20 minutes here. I know you want to do a demo too, so we can however much you want to elaborate here.
Sure. Yeah. I'll be kind of brief on this. It really kind of boils down to a single moment, which is it's kind of fun because usually there isn't like, for a lot of things there really isn't that like, oh, this is the reason why I became this or did this thing or dedicated the last 4/5 years of my life to like getting excellent at a language. When I was at my like first security job, I was still very kind of green, and I'm just trying to like learn up as much as I can, working as hard as I can. We had this lunch and learn event, and I went to this thing, and it was called misuse resistant code, I think. And so it was like an internal employee, also on the security team, that was giving a talk at lunch over the course of an hour, so we could just kind of like learn from each other about the technical things that we're interested in. And a lot of the talk was just very abstract, kind of high level stuff, like kind of leaning on that like academic type theory stuff that none of that made sense to me. I wasn't exposed to that before. My background was I was just a software developer. I was doing Android development, writing a lot of Java, C Sharp, did a little bit of C professionally as well. But like I wasn't like sitting down learning about dependent types and affine types and stuff like that. So none of that it was going way over me. But near the end of that talk, while I was distracted, the speaker had mentioned that they were going to show a demo. And in the demo, they it's my favorite demo. If I've tried to sell you on Rust before, in the chat, you've probably seen me show this before, but it was an authenticated user like struct in Rust. And you can think structs as similar to classes, but the demo basically showed that because of Rust's type system, you could express the idea that when you call login with the user object and you get an authenticated user object, you could call do work or do some sort of work function on that a couple of times while you're logged in. And then when you call log out, you could express with the type system that you can't talk about that object anymore. And this isn't a runtime thing. This is like verified at compile time. So I could have a line of code that's like, auth user.do work and then auth user.logout. And if I wrote auth user.do work, that's not a runtime error. That's a compiler error. That's a compilation error. And I thought that was like incredibly impressive. I didn't know any other language that was doing that. I think a lot of languages, when they come out, you can kind of boil down some of their features into just syntactic sugar. Like this might be doing a little too much damage to like Golang's channels construct, but like I can do channels basically, like not as elegantly by any means, but like I can do channels in other languages, right? Like other languages have async. Like I can do this type of like Go routine equivalent stuff. It's going to be a lot more code. It's going to be a lot more ugly, but it's not a new thing. It's just a lot easier and brings kind of async to more people, which I think is great, But this is something that I can't emulate with another language, like this ability to kind of like stop an object dead in its tracks. And I just wanted to know more. So I felt like that was going to be the future of secure programming.
That's super interesting. You already had me in the first 5 minutes of this. You already had me thinking, man, I should learn Rust a little. But I think that's super interesting because I like the way that we all get introduced to languages is so different. I learned Go at a hackathon in like 2017 and like basically made like a DRM platform using like Ethereum tokens, like way back then. And that was like my first time ever using Golang. And I learned it because there was a Golang influencer there, and he was like telling everyone like use Golang for your projects. And I see Gophers in the chat. Well, we love that mascot. So yeah, I know Rust is like almost as energy efficient as C, right? I think I saw some normalization of like energy usage and like C. If C is a 1.0, Rust is like a 1.03 or something like that. So I think that's super interesting too. And I think like you said, the overhead in all these other languages trying to do like a similar thing, you're going to be writing a lot more code. You're going to be maintaining a lot more code. There's way more. What's the word I'm looking for? There's a lot more code that you have to write to do the same thing, right? And like you were saying about Rust, if you're saying, okay, this field is going to be a phone number, right? You can like sort of parameterize, right? Like what is allowed to be in there. So it's like that joke, like, hey, I heard you like parameters. So you put parameters in your variables, So like we put parameters in your parameters. But I think that's really cool that you can like restrict, something and say like, okay, this float can't be 3,000 digits long, right? This float can't have like 0.000000. So doing that in like a language native way is like pretty interesting. So yeah, you've definitely convinced me. I'll do some challenges. I think I'll do some little code puzzles with Rust, try to learn it a little more. But so I think that's cool. We talked a little bit about what led you to learn Rust, but and we talked a little bit about this. But can we go over once again, maybe for new folks who just came in through this raid? Shout out to our raider who was just here, TDV. Thank you so much for the raid. And can you tell us a little more about the new ideas that like Rust brings to the table that is very like particularly unique to Rust, perhaps?
Yeah, I'll try to be brief on it because I don't want to spend the whole time. I'll spend the whole time talking about Rust. I have no problem with that.
We need to set up a follow up already.
Yeah, exactly. Yeah, but I'll try to be brief on that. But Yeah, I talked a bit about that, like being able to terminate the life of an object in a sense, no longer being able to refer to it in code. We this is done through an operation called move, which is just kind of a part of a bigger story of ownership and borrowing, probably some terms that, if anyone's Rust curious, have probably heard before. I think that is the ownership and borrowing system is the heart of Rust. It's what kind of gives Rust the ability to be memory safe and thread safe. And it's like actually really intuitive. I kind of describe it as intuitive in hindsight. It's kind of funny because when I finally understood it and it kind of like really made sense in my head, I was like, wait, actually it feels like every other language is doing it really unintuitively. Like when we're people, we deal with physical objects. Like if I handed you a book, I can't like highlight the book anymore. It's not in my hands, and like that's the model Rust kind of chooses. Whereas other languages, like I can pass an argument to a function immediately after. I could just do whatever I want with that value, and it makes no sense. It's not it doesn't make any physical sense. And so I kind of like that model, and that's kind of like the big thing. I think another thing is that Rust has a lot of cool type level functionality in like composable software with like the trait system. Algebraic types is another fancy academic sounding term. It just basically means enums, right? But the way the enums are done in Rust actually is really powerful. And I think pattern matching is another interesting thing. But other languages are starting to pick up pattern matching, so it's not necessarily the differentiator that it used to be. Like Python, for example, I think is picking up pattern matching now after the popularization of it with Rust, I believe.
Wow. So Rust is really just like pushing other languages forward, and from what it sounds like, influencing the the baseline of what we're expecting in programming languages.
Mm-hmm.
So sounds like it's really really well worth it to learn. So what was the process of learning Rust like for you, and were there some difficult things to learn? We sort of talked about your Jimmy Neutron like aha brain blast moment, right?
Yeah.
And I think those are always awesome when learning a programming language, when you're like, oh man, I finally get it. Like I thought I understood it before, now I actually get it. So was there anything that was like particularly difficult for you to wrap your head around because it may be unfamiliar just due to your previous languages learned, or like anything that like helped you particularly during the process of learning Rust, like something that you use as a crutch perhaps?
Yeah. Wow. The process of learning Rust for me was very difficult. Like I'm sure a lot of people have heard Rust is hard to learn. It really earns its reputation at times. I will say that nowadays it's so much easier than it used to be. Like when I was getting in, and I'm sure the people before me even had a harder time, but when I was getting in, we had the old model of how async worked. And, I'm very project based. So I'll like, when I want to learn a language, I can't just like sit down at Code Academy and just kind of grind out, a class or something. Like I have to be building something with it at the same time. And then when I run into something, I can just Google it, and then I'm picking up kind of through osmosis that way. So I started off with a project, and I think I was like working with HTTP at the time, and eventually wanted to build like a DNS brute forcer. So I was kind of looking into some of the libraries that the ecosystem had, and this was like kind of when async was still very new in Rust, and the original model was horrid. It had a heavy rightward drift problem, which if you haven't heard that term before, it's just the symptom in your code where you'll find that you'll be indenting and indenting and indenting. So if you've like worked in Java or TypeScript and you've had a then, like you may be familiar with that problem. But it was like that to the extreme in Rust originally. So it was very bad. Lifetimes were a lot harder to work with. Lifetimes is a Rust concept. Probably don't have the time to kind of dig into all the things that it implies and means here, but
you need a whole episode for that, right?
You need a whole episode. It was very difficult to get into before. I actually quit Rust when I first started learning it. After like a month and a half, I threw my hands up and said, this language's async feature is this bad that I'm just going to quit the rest of it. But I went back to it because I couldn't leave that on the table. And shortly after, they revised async, and it's like infinitely easier now. They had a non-lexical lifetime update, which made lifetimes a lot easier for people. There's a lot of things that have made it a lot easier. I think in general, if you're trying to learn a language, Rust has the book. It's on the Rustlang website. It's just an online kind of thing you can go see and learn from. It's actually pretty excellent. I usually also enjoy the Rust subreddit, which a lot of people ask good questions there, and I kind of learn through osmosis answers to really interesting questions. And then lastly, huge shout out to Faster Than Lime's blog posts. If you kind of like that long, rambly style stream of consciousness, but really technically excellent style blog post, Faster Than Lime is the blog post, like the blog for you. Like, go, you'll absolutely enjoy those reads. Huge fan. Learn
Thank
a
you. I
ton
just
from
dropped that in the chat for everyone.
Yeah.
Here it is, folks. For folks watching the VOD, oh, whoops, there is the link. Go ahead and take a peek. So, most serious question of today: have they made you a subreddit mod yet?
No. I don't usually post on there. I'm just a lurker.
I don't know. I think an honorary mod is in order, right? So
yes,
subreddit mods, you heard it here first. I know we got some of you probably in the chat. Come mod Donut for us. So
I accept my
continue.
Democratic nomination. Yeah.
So you can continue doing this work. Yeah. So that's really awesome. I think learning by doing is also something that I think a lot of us probably share, right? Just like sort of the hacker's mindset, the hacker mentality, right? Learning by doing. Failing a lot, giving up a lot. So I think we all need to drop W's in the chat for Donut, because not giving up is a big W, and it's very easy to give up. So I'm dropping a W. I hope y'all drop a W for Donut here. Show him that we support his endeavors here, and we're glad that he's here giving us this chat. So we know what's up with the Rust now. Like, that's super cool, and I know you're working on something called the Dacquiri framework for authorization. What you call it, a framework or a library? I'm a little rusty on my Rust terminology. So.
I usually refer to it as a framework, but at the end of the day, it's just a library, right? But it's basically just a framework.
Awesome. I like it. It seems a little laissez-faire. That's very Rust to me. So this turns authorization vulnerabilities into compilation errors, correct?
Yes.
Can we talk about that a little bit? Because I think, I think we got a lot of security folks in here. We got a lot of programmers in here. Folks, ask questions, drop questions. We're going to go back at the end. I'm going to try to hit some of the ones that are already in there. But if you have any questions about anything we talk about, just drop them in chat. We'll try to go over them at the end.
Yeah. So, let me tell you a little bit about Dacquiri here. As you said, Dacquiri is a framework that turns authorization vulnerabilities into compilation errors. And this, I used to kind of pitch it slightly differently. I used to call it an authorization framework with compile time enforcement. I think a lot of people hearing that would probably assume that, oh, well, Dacquiri, what that means is that Dacquiri's checking authorization at compile time, which is not accurate. Dacquiri is kind of like the meta level above that. Dacquiri checks your checks. So what Dacquiri does is it tries to flip a lot of authorization frameworks on their head, where maybe you've worked with Spring, you can kind of do this with Django, but maybe you're building a web application. Though I will say Dacquiri is agnostic of the code you're writing, so it doesn't have to be web, like a web app. But say you're building a web app and you have endpoints defined. Usually your authorization frameworks in those web frameworks are going to allow you to annotate your endpoints and say, like, only admins can call this, or only, users of this particular role can call this endpoint. Or users have access to a particular object can call this endpoint, as is the case in Python or in Django. And they work, they kind of get the job done, but it kind of feels a little backwards in a sense. Like, which one, like, how do I know which, role should be used? If I add a brand new endpoint, which role should have access to this thing? I have to make my best guess, maybe ask a product manager, which, you should do anyway. But it doesn't, like, what if their suggestion isn't actually cohesive and breaks security for the rest of it? I think there's this really good vulnerability that I encountered in my time professionally many years ago, where there was this resource. I'll just kind of be vague about it, but there was this resource that had proper access control on it, where you could, like, share this with other parties. But then there was a separate, like, thumbnail generator that did not apply those access control policies. So you can kind of give it a document you didn't have access to, and then now you have a thumbnail of this thing you couldn't read otherwise, right? And, like, you could totally imagine two different developers writing this. One's picking, like, you have to have access to this document, and the other one's just like, you have to be signed in. And, like, that's something that could totally just happen. And, you're not going to find out about that from a compiler. Maybe you get a test that fails, but that's only if you manage to think about writing that test. Kind of felt like a sloppy system. And I really wanted the code to inform me what the authorization policy was, not me dictate it to the code. So I built Dacquiri to allow me to annotate arbitrary functions with an access control policy, and said only allow users that have access to this document, and if the user's account is not in a disabled state, like only in that condition should someone be allowed to invoke this code. So it doesn't check those conditions at compile time, but it validates that all code paths that call that function have checked those conditions ahead of time.
So I think that's like, as we know, right? Like usually when authorization fails, it can be catastrophic for folks. Can you tell us like what problems we're solving with this? Like when it comes down to it, right? Like, could we talk about like, how existing frameworks deal with authorization?
Yeah, I think like I mentioned before, I think usually existing frameworks, they kind of deal with a very limited view of what kind of security controls we are typically putting in place.
Yeah.
So usually they're like role-based access control, probably referred to as RBAC. Maybe you've heard that, you all heard that term before, but it'll usually be like only this particular role can access this. Sometimes they get a little bit more complicated. I think Django can do this, probably Spring as well. But it depends on whether or not developers are using that functionality. But sometimes it'll be like you have to have access to a particular object that's being talked about in the request, and like this is like nice and useful. But if that's only if you remember to add those things, or if you somebody brought that up in a design discussion, like, oh, we should make sure that this condition's checked because it's like really important to this other service to maintain their security model. Like I've never had a conversation like that, because who knows what the access control policy is at your organization. If your company is built on like hundreds of thousands of lines of code, millions of lines of code, like no one knows how all of that works. And
Yeah.
I doubt anyone has a good cohesive model of how it works. So like
true.
it's ridiculous. Like
Even at smaller shops, really, like even if you just got like 200 developers, like even then, good luck, right?
Exactly, yeah. And then it gets really complicated in the microservice world, where it's like this service has their own thing where they're kind of expecting the caller to do something before they send a gRPC message over. And oh my god, that's never going to happen, or at least not consistently.
Yeah, definitely. There's so many things that can go wrong, right? Like not even getting into like technical bits like race conditions, etc. But I think just having a strongly typed language, right, where states are not. I think enforced is too light of a word, right? States are centripetal to it all. So maybe we can talk a little bit about like what's the like makeup, I guess, of this project, right? Like how does it actually work? Because I know the models for authorization, a lot of them are fairly similar now, right? Like we talked about RBAC, right? And then there are a couple others, right? Like I forget the military ones, or there's some military ones like FIDO or something.
Like MAC, mandatory access control, stuff like that.
Yeah, mandatory access control. And then there's a couple, there's role based, and then there's something based, which is like older and now like nobody uses it, right? So it's been a while since I took an authorization class. But I know that it's made up of 3 core components, just like most authorization frameworks. Can we talk about that a little bit? Like just kind of how this works under the hood, perhaps?
Yeah. So funny enough, the name Dacquiri is originally inspired by discretionary access control, because when I first started writing code, I was gonna like build a discretionary access control system, just kind of like for fun, just to see what that would look like. And I by the end of the first commit, I accidentally built an attribute-based access control system, and I was like, dang, I already used the name. So I got locked into the name Dacquiri, but I just felt that was kind of funny because we were talking about other systems. But I think that's a great segue into the question you were asking, which is about like what are the core, like how does Dacquiri work? Like what is the core kind of concepts here? Attribute-based access control. So the 3 core things that Dacquiri works with are entities, attributes, and policies. So entities are pretty simple. They're just basically, if you're talking about access control, they're just kind of like subjects and resources. Dacquiri doesn't make a distinction between those two at the like entity level. We'll just call them entities. It's like they're all entities, and then they can have weird relationships with each other and themselves. So like, something that might be a resource in one particular constraint could be a subject in another, because like I found that in the real world is kind of how authorization actually happens. Then there's attributes, which I kind of mentioned that before, but attributes are really the same conditions that you would have checked in an if statement or any other kind of control flow that you would have used. So if you had a line of code somewhere that was like if document, dot is enabled, or like or if you had like an if user dot on team or something like that, like that condition is an attribute. So it's like just the statement about these objects or the object in itself and their relationships. So that's an attribute. And then policies are how you define which set of attributes for which entities have to be true and checked ahead of time to allow someone to call this function. And that's how Dacquiri works.
Maybe to boil this down for folks, like an entity would be yourself, right? Like you're Nathaniel. It could be yourself. It could be something else. It could be a service. It could be a subset of services. So there's an entity, right? And then there's an attribute. Like I could say you are a security engineer at Robinhood. If you're a security engineer at Robinhood, like we give you this attribute, and then we say you can access these things in such a manner. Like you can access this as root, you can access that as blah, blah, blah. So like those would all be attributes, right?
Yeah, those yeah, exactly. Yeah, the subjects is just like a thing. It's like a noun. It's like, do I have a user object or a session object or a document object? Like these are good entities. And then attributes, like you said, it'd be like is security engineer or request it is on VPN IP range.
And then you're applying those like policies to those attributes. So like is security team gets your root on XYZ box and doesn't give you access to marketing and blah, blah, blah.
Exactly. Yeah. So we take those policies and then like apply them to a function and just say like this policy applies to this function, and it can only be called if these attributes are true, and these attributes apply to these subjects. So
excellent. So if any of those conditions aren't met and you're trying to make something like that, it's going to throw an error, right?
Yeah, at compile time too, which is really nice.
Sweet. So if let's say the compile time stuff didn't exist, if it was running at runtime, could be some catastrophic errors, right? When you're hitting these edge cases.
Yeah. I mean, if it were at runtime, you may not even find out about it too. Like it may be something that you find out way down the line when you have like NCC hitting up your door, like, hey, it's pen test time, and then they find out that you have this broken authorization model that allowed them to like access privileged stuff. So
totally. And to folks who maybe haven't, maybe some folks are developers, maybe some folks who've never seen a pen test report, what he's saying is way more common than you'd think. You see tons of authorization, authentication failures, weaknesses, circumventions. It's definitely very, very common. I think at least everywhere I've worked, we've had authorization or authentication issues where they were difficult to solve. They were intrinsic to the system, and it was because of how we'd set up for the future of authorizing usage, right? So that is definitely a step in the right direction. Doing all this, making it easy to use, easy, like failing securely, right? We say we want to default to close, we want to default to secure. We don't want to default to open and default to insecure, right? So this all is totally awesome stuff. So maybe for folks who are just hearing a lot of these words for the first time, they're just hearing about entities and policies and all this stuff and attributes, right? What's the difference between authorization and authentication, or auth-z and auth-n as we usually refer to them?
Yeah. So with authentication, that's the process of just like verifying that some party is who they say they are, and we typically think of that with like usernames and passwords. Sometimes that's done in other ways as well, but yeah, that is just going to be like who you are. And then now that I know who you are, authorization kind of comes into the story, which is like, okay, now I know your identity, but like, what does your identity get you in terms of accessing particular resources or performing particular actions? So that's the process of verifying that a party has access to perform an action or access a resource.
Gotcha. So authentication's like you checking the door and being like, oh, it's Kyle. And then authorization is kind of like, okay, like you can access these parts of my home.
Yeah, exactly.
Don't go to my bedroom.
Yeah, exactly. Yeah.
Perfect. So I think hopefully that makes sense for everyone. And if you have any questions, just drop them in chat. We are here to help. So I think we have a demo plan, don't we?
Yeah. I'll be happy to show it off here. Let me see if I can share my screen here. Okay, and it should be screen 1. Yeah, that should work. Cool. Is that showing up?
Let me plop it on the screen here. Here we go.
Cool. Alrighty. So I'll just kind of walk through this. I built 2 apps. It's basically the same app, but the first one is without Dacquiri, and I just kind of want to highlight what kind of like the typical problem is when you're not using a framework that can like Dacquiri. So this is just a simple web app. It's got a couple of different methods. We've got it's like a document kind of document kind of service. So you can just like fetch document contents, some metadata about it in a preview. I kind of talked about this example before. So we have this metadata endpoint, and in this model, anyone can fetch metadata about a doc to learn about like who made it and when it was created, stuff like that. But here we're going to fetch contents, and notice I check like 2 things. I check that the caller owns that document at that time, and I'm just going to kind of I know it's Rust, so some people may not know how to read it. I'll just kind of explain it as I'm going. But we do a check here after we get the document from the document service. We say like, okay, does the user own this document? And if so, like we can go and check that. But like, is the document still in an enabled state? Like maybe an administrator came in and had like locked or archived a document, because legal reasons, and so they need to keep that like under locks or under lock and key. So we have like 2 conditions that we have to check here, and if both of those have passed, then we can return like the title and the contents of this document. Now we have this new method here, which is this like fetch document preview. So we're going to implement that really quick. So we're going to get the document ID here. Oops, I should probably put session and path. So path.into enter. So this is just going to get us a document ID. So to make a document preview, at least in the way that this code's been written, we need to get the document. So let's get the document, and we go document service, get document. Here's the doc ID. And now we're going to create the preview. So let's create the preview, which is going to be also document service, generate preview, and we can take the document contents and pass that in there. And now we can just kind of return not pull it in, but yeah, we can basically oh yeah, we can just do that. That's right. We can just return the bytes that came back from our preview. So we can assume that the preview is like an image file, right? And so now we have the raw bytes. We're just going to send that back. We can compile this code. It compiles. This could run. And I can now start hitting this preview endpoint and start getting previews for my documents but I have just introduced a vulnerability. Because if you'll remember, like in this other code, we did a check here. Like, do I even own this document? Is this document even enabled? But I didn't do any of those checks over here, and the code compiles, the code would run, and this would show up in a bug bounty report or a pen test report, or maybe someone would be using this to start accessing documents they shouldn't. And so this is the kind of thing that, like totally happens all the time. I have personally seen this exact thing happen. And I think it's just like a powerful story on how authorization is kind of broken. So this is the Dacquirified variant of that. So we kind of same type of app, same kind of endpoints. None of the code here changes. We'll kind of get into what happened here, and we have the same kind of preview. So the first thing to kind of look at is let's talk about the attributes. I talked about attributes before. The way attributes work is you just basically define a function that can take in the objects that you want to talk about, so the entities. And in this case, we have a user. It's the session type, and then the document metadata. And we perform that check, right? We do the if statement that we saw in the previous code. And, when I designed Dacquiri, I could have just had it return a Boolean value, but I wanted to give really the power to do rich errors. So, that's why we have this a little bit more kind of gnarly looking okay or error value being returned here. But we just annotate it and say this is an attribute and this is called owner. So if this would mean that the user is an owner of the document here. So that's what that means. It's really easy. I can just add more functions and define mark them as attributes and would be good to go. Now let's actually see how we're applying Dacquiri to that get document method. So we have this get document method that we've kind of moved a bit. We're kind of just returning some fake data here, but you would imagine you'd be fetching from a database or some other service internally. But note here that we've put this policy in place. So we described these are the entities that this policy requires. I need to have a session and I need to have the document metadata. These are just like, what objects do you have to give me ahead of time before I can even reason about them? And then this guard describes the set of attributes that have to be true and checked ahead of time before you could call this method. And so in this case, we're just saying that the user, which is the session object, is owner. And that's this attribute we defined over here for the metadata, which is this document metadata we provided. Now, what's nice is that when we implement our get document method, we don't need to do any checks. We can just assume that we're entirely authorized ahead of time. And so I can just say, hey, get me my document metadata that I described in my policy. And, I'm using that to kind of pass in this document object that's coming back. But usually, you can imagine I would take this and I would write a SQL query or a gRPC to some internal document service. And I would need the data, the document ID that might be inside that document metadata to make that request. Okay, so now we've guarded this function. How do I even call it? How do I prove that this condition is true? The way that's done is, we're kind of like keeping a lot of the same code before. We have this like path.inner into, we get our doc ID, we make that get document metadata query that we did before. Now we have the document metadata. And now you'll note that I'm taking the session object and the document metadata, and I'm basically combining them. I'm saying like, hey, add these entities together. And you can keep adding objects. So you can keep just kind of stuffing objects in the Dacquiri bag of entities. And then I'm able to call this function suddenly on it. It's this function, if you remember the name, check user owns document, came from our attributes just over here. It seems like we wouldn't be able to do like a dot something. It doesn't seem like it's a method that's on an object, but due to the power of Rust type system, that's something that I can actually do and express. So now I can suddenly call this method and it says like, hey, check that the user owns this document. And if it's an error, by the way, for those who haven't seen Rust before, the question mark is kind of equivalent to doing if error not equal nil, return, nil, and then the error condition. So it's an early exit if an error occurs. So I'm doing this check that's like, hey, check that the user actually owned the document. And if there was an error, please just leave. Like, we're done here. We failed. Just like those if statements that we had in the previous version. And now that I've done this check, I can actually call get document. And this code builds and runs fine as well. You can kind of see down here in the bottom left that, the build finished properly. But how do I know that Dacquiri is working here? Well, say I didn't do that check. Say I didn't run this check that, validated that we own the document. I comment that out. This is actually now a compiler error that it'll kind of do. It's a little bit nasty. I've got Dacquiri sometimes trying to show nicer error messages, but this is suddenly now an error. And I think one thing that is really cool is like, yeah, sure, that makes a lot of sense for when we're working with existing like code where someone built this like get document function. It makes a lot of sense, like how I might have to like appease the compiler to kind of get all the proper checks done ahead of time. But it's also really cool for when you change an access control policy on the back end and you want it to tell you all the places that need to add new checks. So as part of that, we'll just do a quick demo here where I can say like, okay, let's create an attribute called enabled. So pub fn check document enabled. We'll take the metadata document metadata here, attribute result, app error. If metadata enabled, then it's okay. Otherwise, it's an error, and it's just going to be, we'll do like another authorization error here. Okay, so now we have a brand new attribute. Yeah, it didn't write any bugs. And now we're going to go update our policy. We're going to update the policy to say that not only does the user have to own the document, but the user, or that the document also needs to be in that enabled state. So it's pretty easy. We just say metadata is enabled. And now if I build this, Dacquiri is going to check all the call paths, any place that tried to call get document, and it is going to ensure that both of these conditions are true. And you'll notice that it is no longer true. We didn't do the check here. So now I can go basically through the list of errors on the left-hand side here and say like, oh, this is a place that needs to do a brand new check to abide by our access control policy. So that's the check document enabled. That's pretty easy. I just kind of throw that in there. Question mark like that. And bam, now suddenly I'm complying with the access control policy. So, yeah.
Awesome. So I think, that was super informative. We really learned a lot. I don't know about y'all, but I feel like I'm motivated to get started with Rust here. How about y'all? Anyone going to get started with Rust? Anyone getting started with me? Yeah. Who's getting started? Let's see it. Let's see. Show of hands. We'll see. Watch. I bet they're gonna drop some. I know we got some people here who are about to start Rust. I think Bash Bunny. Have you been peer pressured sufficiently by chat? I think so, right? All right. I'm dropping this Discord here in case you want to get started. I drop programming challenges in here, CTF challenges, Donut streams on Twitch. Donut, is your name the same name on Twitch?
It is, yeah.
Follow Donut on Twitch. Yeah. His streams are good. His streams are great. Here, let me get that link out here. This is Donut's Twitch. My Twitch is the person spamming chat right now. I do cybersecurity news and all sorts of things. Yes, Donut does stream. So
yeah, that's fair.
It's fun. They're fun. I usually throw on streams when I'm doing something else, playing a game. So I like having that noise on. I think Donut does the same. Donut comes through to my stream sometimes. It's super fun. So yeah, I think that's probably all we have time for today. I know there's we do have one question in chat. He is also excellent at Among Us. That game gives me incredible levels of anxiety.
Oh, so, I'm a shark in that game. It's disgusting.
I feel like my heart rate goes up to like 112 playing Among Us, So we got a great question here. Hi guys, what do you think about the Mark Rustnovic tweet about we should declare C and C++ deprecated and start using Rust in the future? And I see Donut is smiling. I think Donut's having a great time.
Yeah, I was incredibly excited by the tweet, just because it's another sign of a large organization recognizing the value that Rust provides. I think a lot of that is in the context of the memory safety stuff that I talked about before, which, I mentioned a lot of people really focus on that. And it's not bad. It's really powerful stuff. But like the combination of being really fast, but also memory saved is like very useful for a lot of types of software, and especially the types of software that Azure, which is who this individual is the CTO of, the type of software Azure is building is the type of software that benefits heavily from being written in Rust for those reasons. And I find it kind of funny that there was a lot of people pretty mad about the C and C++ like being declared deprecated here by them. But I think if you kind of view it in the lens of like, for those types of organizations, it makes sense for them to only be writing their software in Rust because, we talked about before how important having, an SRE on call that's not horrible is. So if you're running services of production and they're falling over all the time, or maybe you get a security team has to deal with memory exploitation of some of these services because they're written in C and C++, that's a very scary place to be in. And so I think this really kind of helps make it easier for companies to kind of build high performance, resilient software in the future. And I think that's where Rust is really going to slide in for those places.
Totally agree. Just from my very limited understanding of Rust in comparison to C, C++, and Go, and basically all of those languages that are usually seen as being very fast, very optimized. There are some intrinsic security deficits that are just the result of how the languages were made, how they were designed, right? The requirements and capabilities of that time, right? So, progress is good. Progress should be welcome. Are C and C++ deprecated? I don't know. Might be a bold statement, right? Might be a pretty bold statement. We see people still trying to hire for COBOL engineers, right? So let's give it 20 years. And in the case of COBOL, let's give it 50 years, right? So yeah, we'll see what happens. I think these languages are going to be around for a while, and switching the Linux kernel over is a huge step because that's one of the biggest users and maintainers of C, right? And we're talking about GCC, and we're talking about all the things that go into using C, and the Linux kernel. I think we when we think about Linux kernel, we think C. Maybe that'll change in the future. When that does change, maybe we could call C and C++ and C# and every other variant, F, whatever, D, whatever you want to use. We can call all those just done, just go away, right? So I think that'll happen one day, but I don't think that day is the day that this guy tweeted out, right? I think it's going to be quite a while. So we're a little over time, which doesn't really matter. If you got any questions, we'll take a last-minute question in the chat. Otherwise, I think we're going to play that funky music and just roll this outro. And Donut, stick around. We'll chat a little bit. And everyone else, thank you so much for coming. We're going to raid somebody who I think is just like a real treat on the platform. Has a ton of really, really cool stuff going on his channel all the time. And it is going to be a surprise. But we are raiding a fun channel. I guess you'll see it when the raid message comes up, right? When I was in high school, I found Sam's learned C++ in 24 hours, and you learned in 24 hours that you hate C++. That's great. That's excellent. All right, everyone. We are going to raid. Let's say hi to our friend, the Prime AG in here. Yes. Ooh. Everyone in chat knows we got some real ones in chat. Let's go. Hey, stay in touch, everyone. Feel free to reach out on Twitter or Twitch. Y'all are great. Thank you so much for the support. Really makes these streams fun. So appreciate y'all. Have a great day. And Donut, thank you so much for coming. Should we have Donut again, folks? I think we should have Donut on again, right?
That'd be super fun. I plenty to talk about, and it's all Rust. So
most def, yeah. D says most def. Bunny says yes. Everyone's saying yes. Recurring guest. Oh wow, maybe we'll start a podcast. Yeah. Feet Picks says yes. So I think we are all good to go. We'll have to run another stream. They're giving us no choice, Donut. I'm so sorry. I'm roping you into another one of these.
They won't let me out of here. They won't get me out of this box.
What's that movie? I keep trying to get out, but they keep pulling me back in. Like The Godfather, right? They keep pulling me back in. All right, everyone. Thank you so much. We are going to end the stream. Y'all are great. Thank you so much for coming through. Thanks for the raid. We love y'all. Have a great day. Bash Bunny, everybody, Security, Nix, everybody, Lustin. Thank you so much. 2-Bit Hack. Thank you, everyone. All the chatters. Y'all are great. Thank you, Feet Picks. We love y'all.
Thanks, everyone.
Peace out.